All right, I want to demonstrate what we could call as a primitive or a simple piece of what a big Web3 architecture might look like. And the concept is that apps log into us rather than us logging into apps. So the MetaNet Academy is doing a lot of this. They're building apps that are demonstrating this. They have a full-fledged client or more than one client that actually show this. But I want to just show you the really simple piece that I think is the root of all of this. And so the best way to show you this is to go through, this is an article that I wrote after I did the whole demo. And so the big idea is that most apps work like this. You create an account, the app stores your login info, and then you trust your app to protect it. So what this demo shows is a different model, and that is that the app does not store your password. It doesn't store your login details. And you prove access each time by signing a message locally. So the app only checks the proof. It doesn't keep your information. So what actually happens? But you click sign in, and the app creates a short message that says, basically, I want to sign in right now. And this message is unique every time you sign in. So the second thing that happens is you take that message and you sign it locally, meaning not on their infrastructure at all. You sign it with a program that holds your private key, shows you exactly what you're signing, and creates a signature. So your key never leaves your local environment. You take that signature and you paste it back into the app. So the app checks, was this message signed correctly? Does the signature match the message? And if it does, you're signed in. If anything changed, it fails. So you can try this yourself, but I am going to demonstrate it with two applications that I built. This one is a Substack guide that I built for my sister, who is not very technical, but she wanted to start writing on Substack. So I built her a guide. But anyway, I put this overlay over the top of it to show you how this identity client works. Let me pop to this is the local identity client. So obviously it is on a command line just to demonstrate and show you how this would work right now. But let's pop back to this app, this Substack guide. And I'm going to sign in with my identity client. So boom, I have a message screen and it says, sign the entire message below exactly as shown. So I'm going to copy this. So I've copied this message. This tells you a little bit about the technical pieces of how this is done, how I did it anyway, because it could be done in a lot of different ways. But anyway, so let's pop back to our identity client. And all right, so let's see. We're going to do this one. So we're running a little program on here that has, so there is a seed stored, and that seed is what gets used to create all the keys that you might need. Now in this application, I only have one key pair. Obviously you would want to do that differently, but again, I'm just showing a primitive here. And of note, we're not going on the blockchain at all here. This is just public key cryptography. But there's an important point to that I'll come back to in a moment. All right, so we'll let us run this. So we're just going to run it. So you recall that I have on my clipboard the message to be signed. So I'm going to paste it in here. And we will paste. So this is the exact message. And then we press enter. And as per instructions, we have to say the word end. And this has to do with this command line interface that I'm in, why you have to do that. And now it says, would you like to sign this message? And yes, I would. So I'm going to say yes. And there we go. So we have the signature here. So let us copy this signature. So the signature, of course, will be unique for any new message that is different. Even if you have the same key pair, if you have a different message, it's going to be a different signature. It will reflect that you control the private key for that signature, however. All right, so let's pop back, and we are going to paste this signature in here. And now, just as it is, I haven't changed anything. And we now are inside the app. So signature verified, you are now signed in. So this is the guide that I wrote for my sister. All right, so now what I want to do is I want to do a different one. So this is a birthday countdown app. So now we have a different, it's all doing the same thing. It just has a new message and it's a different application. So we're going to copy that message to sign. All right, let's clear the terminal and let us run our program again. All right, so now I'm going to paste that message in. And I'm going to hit enter. And I'm going to type end. And ask me, do I want to sign? Yes, I do. All right, so now we're going to grab this signature. This signature is, by the way, base 64 encoded. The only reason I mention this is that is simply a transport thing from this sort of environment to where we're headed. It doesn't have to be base 64 encoded. I just made it that way because it was how this worked. So let me paste my signature in here to this different app, this birthday countdown app, and we're going to verify successfully connected. I have proven control of my cryptographic key. So what just happened? No password was stored. No account was created. I proved that I control a cryptographic key by signing a challenge message. This app authenticated me, not the other way around. I didn't log into this app. So, and that is the future, that you own your identity. Okay, so I'll just show you. My name is Bridget. My birthday is December 4th. And I'm going to continue to my birthday countdown. There we go. Look at that. 324 days, 18 hours, and 15 minutes, and 32 seconds until my birthday. All right, so it's as easy as that. Again, this is just a primitive. So I can show you what it does not do. This is important. This demo does not identify who I am in the real world. It does not store my personal data. It does not prove my age. It does not prove I'm human. It does not charge me money. All of those things can be built or layered rather on top of this primitive. And I'm not saying this primitive is what you should use. I just want to show you kind of the concept and how simple it is. So, and then the last thing I want to show you is I want to show you when it doesn't work. So let's go here and we'll just hit refresh. And here we are. All right, so now we got a new message, a new nonce. We're going to copy that to sign. We are going to go back to our identity client, pop it up here. We are going to clear this window. and we are going to pull up our little app, and we're going to paste in this message. Paste. And we're going to say end. And we are going to sign yes. All right, so now I have a new signature with the same key, which again, you shouldn't, there's ways to mask that or reuse so that you're using a different key, or that it's not, so you don't have the same public key representing your identity, etc. This app's not for those developments. All right, whoops. Let's get this signature. So here it is, properly copied. And we're going to pop back to the sign in, and I'm going to paste this in here. All right, so there's the correct signature, but let me take just 2 characters off there, and let's see what happens. Whoa, look at that. Verification failed. Signature invalid, the encoding for the signature. So there you have it. This will fail if you don't put the correct signature in there. It was coded to do that. What else? So you can try this yourself. I have everything on GitHub, and then I have links to the apps that I built that you can sign into, and you can, if you want to start writing on Substack and you're not technically inclined, you can do that one. Or if you want to see your birthday countdown or your kids' birthday countdown. It is technical, so well, I'll just show you the GitHub. So the README shows you how to do it. And it even has a spec doc if you want to get really technical, and it'll show you, I used actually BRC77. You don't have to. There's other ways to do this. This is just how I did it because I think they're smart people that are building these building blocks out. Anyway, hope that you enjoyed, and go ahead and give it a try. Pick a secret number, that's your key. Multiply G, now the public can see. On the curve, can't fake what you sign. Private stays yours.